button here. Hey, welcome to Coffee Compiler Club. We're here to talk about compilers and language runtimes and typing systems and nil and not the nil and garbage collection, anything and everything to do with language design and implementation. You're being recorded live. You'll show up on YouTube within a couple hours. If you don't like that, bail out. Everyone here is a regular and heard me say this a dozen times over. We have a special guest speaker today, Gilad Bracha. Open mic, ask what you want, but I think we'll start with Gilad saying something about what he's doing in the last 10 years since I've last seen you, and what's Newspeak or whatever is going on now.
Right. Okay, so yes, I will say a few words about that. And I got from Cliff and Cameron the vibe, and it may be my misunderstanding or not, that slides were not the thing here. So I brought some slides anyway.
Slides are totally welcome, and I enabled sharing, so you can whip out Zoom and share.
Yeah, that's what I'm trying to do. I have too many windows. Which one is it?
We were just talking about typing in the wrong window. Yeah.
Yeah, no. Now I'm trying to get Zoom to find the
right
thing.
How many apps do you have open? Yeah, suddenly you can't find it.
Now it doesn't. It is that one, but it's pointing at your, okay, we'll change that. It's pointing at the browser, but it's pointing at your document. And what we actually want to see is this stuff.
There you go.
There we go.
Coffee and compilers. Okay, there you go.
Right. So I have zillions of slides, but since I figured that you don't like slides, I cut them down, and so I reshuffled them. So this is 7 slides to enlightenment.
Excellent. And we don't dislike slides at all. That's all fine. It's just that typically we have an open conversation. People are winging it as they go, but slides definitely show up.
Right. So by way of background to people who don't know what I've been doing, which is probably most of you, once upon a time, I got the best job of my life, which was to actually design a complete new language and system from the ground up. And it was called Newspeak. And that was like back 2006, 7, 8, sort of about 2 years. And then the crash of 2008 put an end to the funding for that. And ever since that, it has become sort of this open source labor of love / obsession that I do in my spare time.
There's half a dozen people here who all fall into that camp.
Yeah. It's sad but true. So, I get paid to do other stuff somehow, whatever, which is not what I want to talk to you about. And so this is what you will have to suffer through. And I'll give you some background on what that is. And by the way, this is a presentation manager that is written in Newspeak that is running the presentation, because I am getting more and more fed up with all the standard tools. Now, the standard tools do a million things that this doesn't do, but it does a few things that they don't do, and that's what I care about. So a bit about the sort of family tree of Newspeak. It's descended essentially from Smalltalk, and with influences from Self and Beta, and smaller influences from Mark Miller's work on E, actually a significant influence, and an influence that you'd never detect if you didn't know my history with Martin Odersky and know exactly where to look. There's something historically from Scala, but it's essentially undetectable.
Okay, wait.
Yeah.
E. Give me more reference on E, and we'll throw a link in the Google Doc.
Okay, so E is Mark Miller's object capability language, the original object capability language, where he invented the object capability model. And again, if what I'm talking about doesn't make sense to people, ask me, and we can go on any number of tangents on the background here. But we will talk a bit more about object capabilities shortly, because Newspeak is also an object capability language. So E, I could find a link if you haven't.
No, it's been found already and thrown in the Google Docs.
Yeah. Okay, cool. So these are influences. I assume certainly Cliff and Cameron know Self and Small, all those influences, and probably Beta. And if you don't and you're interested, along the way, I will, if we get that far in the slides, I mean, we have to get through 7 slides. I don't know if I'll manage, but if we get through them, we will have explained where these things play in. But this is sort of the big picture. So what is Newspeak? This is the buzzword-oriented definition here on the slide: dynamic, message-oriented, class-based object capability programming system. And I say system, not language. Of course, it is a language, but in the Smalltalk tradition, there's a big emphasis on the tools and environment and so forth. Unlike Smalltalk, you can separate Newspeak cleanly. There is a clean language definition that you could write a dull batch compiler like you guys often end up doing, but it's not in the spirit of the thing. The spirit of the thing is that there's this interactive environment and so forth, and that actually, of course, does impact how you'd implement it. So I'll go through some. I mean, I assume most of these buzzwords mean something to you, but I'll go through the interesting ones and what that implies. And I expect along the way we'll probably have plenty of discussion. So the most important probably thing among these buzzwords was message-oriented. So messages have different connotations to different people. To most people, this may imply asynchrony, not necessarily here or not primarily here. There is an actor model in asynchrony, but the messages here, the term comes from the Smalltalk usage. It just means, late bound, virtual method calls, essentially. So concretely, this means this: all names are late bound, and we mean all. So sure, methods. So methods are always virtual. There are no oxymorons of the form static methods or final methods or any other form of Fortran subroutine masquerading under the name method. Everything is late bound. But that's also true of variables. So essentially, everything goes through a getter and setter. You never, ever have a direct reference to a variable, which means you can override variables with methods and vice versa and things like that. Probably the most interesting part or unusual part is this applies to classes as well. So when you mention a class, you're actually, again, referencing a getter method that will get you the class object. And the class object, the typical usage of classes is the primary use is to construct instances. So you are probably used to most languages where there's some sort of constructor-like thing, which is a very static construct that you can rely on and know this is a fixed thing and this is going to be this class and we're going to instantiate this particular class. That does not happen here. It's all late bound. And if you get the class, then you can call a method on it, which will be a factory method that will manufacture instances or what have you. But you don't statically know what that's going to be. And again, it's subject to override and things like that.
So you can,
yeah.
Sorry. So you can have virtual classes the right way. I guess that's the intention.
Yeah, virtual classes. So that is exactly the beta influence. Yeah. But
I'm sorry, how does that work? I'm not aware of this.
Okay, so virtual classes, we need to, okay, at least there's one person who knows that because they asked, but the idea is, again, that you can override classes. So think nested classes, but not like from Java, not the train wreck. Nested classes were originally done in this language called beta, and they were done right. And as a point of history, which I know for a fact, this was a big influence on Bill Joy and John Rose and whoever was doing inner classes back in 97 or so, 96, 97. And I am sad to say that they misunderstood how they worked in beta. They simply missed the main point of how they were supposed to work. Or they either decided that they didn't want it that way and it wasn't important, or they never realized, I don't know. But
wedge it into the existing Java virtual machine.
Perhaps, whatever the reasons. I mean, they're very clever people, but John is way clever than I am, but they did the wrong thing with it. It became this train wreck that everybody, that I salvaged what little could be salvaged.
Don't give me the judgment call on it. Tell me what it is.
Oh, you invited me to talk, and with no judgment calls, you've gone to the place.
Some are okay. Yeah, okay.
Fine. I will explain what it is and what the problem is, or where the misinterpretation is. So if imagine nested classes as something that was late bound, so you could override them in a subclass, right? That's the fundamental thing. Virtual classes in the same sense as virtual methods.
I sometimes
I have to program it in anger to understand what it means for a programming model.
We'll get to that.
Sometimes I try to explain it that basically your new method or constructor is dispatched from the outer class instance. So you have an instance of some outer class, and then you can do .new inner class, and the kind of inner class you get is based on the dynamic type of the instance, not the static one.
That's how we do it.
Probably works in Java.
That is true. That is an accurate description of a typical implementation. I guess you are mainly implementation folks. That's not how I'd look at it, but it's absolutely accurate. And so this gives you a lot of flexibility. So as we'll see, if we get that far, you can define a whole library with classes in it, and
So,
then
Gilad, that's hilarious. That's hilarious because I didn't realize that was in that language, because when they were first introduced to Java, we actually implemented them as virtual child classes, not in the JVM, but in the IDE and compiler we had for Java at the time. So
and then
we
you
actually
broke it.
And you were told
no,
that this
no.
is the wrong semantics?
Well, no one understood it, but that's actually the way that we build message protocols in coherence. Those are all virtual child classes in the various clustering services.
Nice
So,
background,
so
by the
it's-
way, Cameron.
thanks. You recognize that?
Oh yeah.
So yeah, it's a great idea, and Beta had it, and the fundamental point is that a nested class is a property of an instance, just like a method is, and it will therefore be different between different instances potentially, and therefore you have to late bind it. But that also means that you can though take those definitions and play games with them, create variations by overriding and things. So
So I could instantiate an instance of class A and then later decide to change it to be an instance of class B.
that's not what I meant.
No.
It depends on the context.
Well,
What you could do, let me try and give a pretty reasonable example. So this is a problem that arises, with web development when people want to propose some change to the DOM, for example. If you were doing this in Java, you'd have a hell of a time because, well, you'd basically have to rebuild the browser with your new variant of the DOM. Let's say you wanted elements in the DOM to have some new property, and you're investigating whether this is a good idea to standardize or something like that. Now, in JavaScript, it works because you can mess with the prototype, and that's one way around this problem, right? You can just say, in my version, I don't have to rebuild Chrome or something. But in a class-based system, what you basically would do, you'd say, okay, I'm going to subclass the DOM. The DOM would be a outer class, and element might be a class in it, and all the sub-elements, buttons and nodes and all these things, this whole hierarchy would be defined in this library. And if you created a subclass of the DOM and said, okay, I'm going to define element to be super element extended with this new feature, because it's dynamically bound, all the classes that you don't have to mess with, that would inherit from your overridden thing. Just like if you have a method and you override it, other methods that you didn't override still call the overridden method, right? Because it's all being late bound. That's sort of, and so you could develop this whole thing without having to change the original and without having to rebuild anything, basically because, late binding gives you a lot of flexibility. I'm not sure if that helped or hindered, but that's a very real world sort of example.
That helped.
So yeah, there are others. I actually, somewhere in the backup slides I have simpler examples, which we can get to if we want to. So the point being, yes, in this case, even the superclasses, right? So when you define a class, typically you expect, the superclass is a static thing. We know what its superclass is. You don't. The superclass is also a late bound message send. So when you actually create the class, it's going to be late bound, which means that in some circumstances, superclass could change. So that has implications. Basically, everything is a mix-in implicitly because you're not going to be able to tie it to a fixed superclass.
That has
You didn't
performance
mention any.
implications because there's a layout hack.
It means that people like you have more employment. It can be done just fine, but it means that it isn't trivial, right?
Okay, fine.
Yeah.
So you didn't mention Ruby as a influence, but a lot of the stuff I did a lot of Ruby, and so it reminds me a lot.
I did not mention Ruby as an influence. Ruby has never been the slightest influence in any shape or form. Not there. We can go back to the slide. It is, yeah,
Ruby wasn't on that.
Definitely is a non-influence.
Yeah,
Ruby is a non-influence. Okay, but yet all of the stuff that you're talking about is stuff that I would do all the time in Ruby.
well, that would be the other way around then. Ruby took influences from those folks.
No, so I don't know that. Yes, you can do all that in me. I don't know how pervasive it is and how clean it. Well, I know how clean it is, but we're not. I'll try not to go there since Split
I
doesn't.
think Ruby was claiming their influence was Smalltalk, so it may be a common ancestor thing.
Maybe.
I have a.
I mean, I used to do. I have this library that I put out there for doing graph database stuff, and it was all about late binding and message passing and basically. You'd traverse to a new node, it would figure out what type it was and generate a class built out of a bunch of mix-ins from that, all dynamically. And you never really needed to, there was never a class hierarchy, but lots of different variations of classes would appear.
So there's a lot of things you can do once you have mix-ins in some form. And this isn't the only way that you get mix-ins, but basically, mix-ins fall out of the late binding, out the other way around. Here is basically inherent in the fact that essentially any identifier is late bind, and that's the definition of message-oriented. And going back to that genealogy diagram, this comes from Self, right? Self was the first language that actually had this pervasive late binding, but it didn't have classes, but it basically ensured that everything was message send in the sense of synchronous, quote unquote, message send. So this is one aspect that's pretty crucial, and there are others. So yeah, object capability language was on our list of buzzwords as well. And this is kind of the top 3 bullets here are Mark Miller's definition of the object capability model. Basically, what this means is there's no global namespace. That's basically what no ambient authority means. I mean, you can get finicky about that, but Newspeak does not have a global namespace, and that's because you don't want to have things hanging out there that are potentially that carry authority, that can influence the outside world, like java.util. whatever, right? Something that any Java program can just go and grab. Right, it just has to name it, and it gets at it. And so you can get at files and networks and all kinds of things where you might do bad things. So the point of the object capability model is no, you cannot do that. Essentially, you can't do anything unless you're given a capability to do it. And a capability in the object capability model is literally an object which knows how to do something, right? It has a method that you can call that'll do something. And if it doesn't know, it'll give you a result that knows, or transitively the closure of reachable objects. That's what they mean by object reachability defines authority, right?
This is like Cameron.
So
this is, you and your particular model of can't do anything unless I'm go ask the right service or get told or whatever. Which actually I kind of like. It's fine.
Yeah, given the great success we've had with security following the ACL model, perhaps it's time to think of something else. So yeah, that's Mark's model. That was originally done in E, and it's a natural fit with objects. And so I sort of didn't actually set out to do that. I set out to make the language modular, but this falls out. Essentially, modularity and security are very much closely related. If you do modularity right, you end up in this kind of model. So there's no global namespace, and that's one important implication. So everything has to be passed in, right? We'll talk a little more in detail about that probably in a couple of slides.
Yeah.
And the other implication of
That
this
doesn't imply that there has to be some top namespace that all namespaces are children of?
No. That's the thing people have a hard time wrapping their head around. But yes, there is no thing that is the top namespace.
So So
Yeah.
like in the land of most other languages, I have a top level namespace includes utility libraries where, independent from IO and things that can, fire the nuclear missile. I also have shit like array lists as a convenient way to have a global array, and I have a sort utilities, and I have whatever other kinds of fun, easy to grab things that belong in some namespace that I want to have easy access to. What do you do with those?
Okay, so there's two ways around this dilemma. The first is everybody inherits from object. And if you want to call me a liar, you can say, well, object gives you some sort of global namespace implicitly because everyone's inheriting from that.
Yeah. Okay.
And in object, there are a handful of things like string classes and an array and, errors for throwing exceptions and what have you, right? In fact, it's debatable whether error should be there. One thing I'm not claiming any of this is really secure because no one's done an audit and whatever, fine. But in principle, there's a very small number of things in an object, and that's actually one answer. As for the rest, like collections and convenient stuff, no, you're going to have to pass that in. Now, the other cheat, as we'll see, is the fact is that, well, how do you actually get any? Pass it in from where? How do you bootstrap yourself in some sense?
Somebody has to start with it.
Yeah. And so the answer to that is that's in the tooling, right? It's not in the language. It's not in your program. The tooling, like your IDE, you can go just like your file system. You grab, you got things from GitHub or wherever. You collected them and put them in your repo. They're on your disk. That's something external to the language where you've gathered the pieces that you might need. Essentially, our approach is to put them in the IDE, and the IDE, will let you grab these and then assemble them, but you'll assemble them by passing one thing into another.
So at some point, the top level, I'm starting the universe, somebody got this initial token that had like array sort and passes it along indefinitely to everyone underneath.
If they want to, you don't.
Oh, they don't have to. Right. Yeah, you can't sort. Sorry, suck it up, write a bubble, sort, and go away. I mean,
well, you can't do X because you have no business doing X. Not every program sorts. Not every program writes to files. Most programs actually shouldn't, etc., etc. So yeah, you definitely control what.
File IO, I totally understand the purpose on. Utility algorithm work that is sort of side effect free. I'm questioning the decision to say, I have to control this. There's a sea of interesting algorithms that are all side effect free. Do I have to manually choose? You can have, computing the standard deviation and you cannot, and you can have sort, but whatever. I mean, I don't care to.
So from a security perspective, it's true that as long as it is not actually creating an effect on the outside world, from that perspective, there's no reason to restrict it. From a modularity perspective, there's every reason to say that you want to know explicitly what your dependencies are, what things you're using and which you're not, and whether you need to have those. And so,
I guess I'm looking for what's the convenient, easy way to pass along a steady set of things that are common utilities that have no side effects. I mean, separate out IO. I totally agree with IO. There's a capability that must happen there.
Yeah,
but
so the convenient way is define a utility class that has this stuff in it and pass it in.
Okay,
right?
And so everyone
remember,
has
a class is not just one. A class can have classes within it. So a class could be a library. In fact, a top level class that isn't nested in anything, that's essentially a completely separate sandboxed module.
That somehow have it as a mix-in.
So you would have a class called standard library that just had a lot of subclasses in it. That's all the repos.
You could, yes. So we actually have this thing called platform, which you very often pass to people, which you can choose to mock or emulate or attenuate by wrapping it something to restrict things. There's various ways of doing this, but the point is you can gather not just individual methods, but you can gather you can gather everything in a library, of a class in a library. You can gather multiple libraries because of this nesting thing, right? Because
so it's interesting because we actually, what you were calling that top level class that can have other things in it, we call that a module.
Yes,
So I wonder.
so technically what we call a module is an instance of such a top-level class. And you can have multiple instances of these if you want, or you can have multiple implementations that implement. We're getting ahead of, as I expected. There's a slide about this, but we haven't gotten to it.
Well, we can
But,
move on to the next slide.
Yeah, well, let's see. I did want to mention that another implication for implementation and for security
we
is
wouldn't,
that
we
there's an
wouldn't be
access control model.
engineers if we weren't jumping around randomly, right?
Yeah. Hang on. So we'll get back to that stuff. I do want to mention this access control thing. So this is different from E actually. E's story revolves around controlling access by putting things in closures and using closures as a non-permeable, procedural boundary. I've always found that twisted or hard to use, where you kind of, this is what you do in JavaScript all the time as well. We have objects, so basically if objects have methods that are public and not public, then you can basically restrict what someone's supposed to use. So, and that's kind of, and that is enforced by the VM.
How many distinct layers of or kinds of access control? You have public and private, no protected, no friends?
Actually, there is, no, you could debate this decision. There is exact public, protected, and private. And private you could debate actually, but there are those three. And again, we can dig in. Okay, I'm gonna move on to the next slide just so I said that I got that far. Yeah, so this is the slide that was supposed to explain all this stuff about nesting and so forth, right? So classes are, I'll emphasize it again because it doesn't hurt to hear it a bit again. Classes are the only top level thing. There are no packages, templates, units, modules, whatever you want to call them, right? You have classes, but classes nest. So a top level class is, it can act as a package or as a library or as a feature for those people who have followed that particular point of view, where you combine multiple packages into these things called features. And of course, if you needed multiple features, they'd have to invent a new name for that. But in fact, it's all the same. It's hierarchy. You nest things within other things.
Does that imply there's no Lambda? You just create a new class that has a function in it?
It doesn't
has a method in
that. It does not imply that. Well, okay, so Smalltalk, for example, had lambdas from at least partial lambdas. They were a little flaky in certain ways in terms of closures, but having closures or lambdas or something is completely orthogonal to this. There is a syntax for those. The truth is, of course, it's an object-oriented language, so these lambdas are actually a class called block that actually has its own definition and so forth. But there's a syntax to write a lambda as you kind of would want to do. So in that sense, these things are sort of separate. Hopefully that answered that question. And then let's see. Yeah, we talked about beta versus Java and the fact that it's an instance property. And yeah, there's no surrounding scope, so they're a sandbox. So essentially anything that such a class needs to use beyond like those things that were inherited from an object has to be passed into essentially the constructor, or what we call the factory method, right? It has to be sent into it. And I can demo this and we can get into those details probably after this overview, if anyone is still alive and cares. So yeah, we've actually talked mostly about this slide already. Then I want to mention like what were the whole goals for this, or a bit about the history of this project. So there are 4 things here. This was basically an attempt to deal with issues that I saw with Smalltalk. And Smalltalk is, I'm a Smalltalk fanatic and I love it. But these 3 points here are not its strong suit. Essentially, it's pretty weak on interoperating with the rest of the world because basically the rest of the world is disgusting and primitive, and why would you want to touch that filthy stuff is kind of the underlying meme here. As for security, it is absurd. I always tell people, Alan Kay has lots of these wonderful aphorisms, and one of them is, if you want to predict the future, the best way to predict the future is to invent it. Well, the thing about these people is they did not predict viruses and computer crime and all these things, and therefore they did not invent anything to deal with it. On the contrary, in a typical Smalltalk system, you can do anything to anyone. If I pass you an object in, well, I can find its class and I can change that object, anything about it. I can change all instances of that class anywhere in the universe while I'm at it, and its superclass, and there's no limit to what you can do, right? It is impossible to even remotely think about securing it, right? These things are totally in conflict. And it isn't, there's essentially no modularity. There's a sea of objects. I mean, there's ways you can build, people have nice tools and they build things, but really it really doesn't deal with these issues. So Newspeak tries to deal with this, and I think rather well. The one thing we're trying to preserve is that having that while having what I'm calling it reflectivity, often in the Smalltalk world or in other communities, it's called liveness. But you guys being compiler guys, liveness might mean something different to you, so I avoided that word.
But it means, reflectivity means something, yeah.
Yeah, reflectivity from reflection, right? You can do a lot of stuff. You can basically modify the program from within itself in any way. And how do you reconcile those is kind of part of the project. And basically this boils down to the fact that use a mirror API, and mirrors are a capability, and that kind of lets you have your cake and eat it too. But it also has huge implications for implementation, right? Because essentially, you have to be very careful when you can allow yourself to nail anything down. Now,
do you feel like that last one is in conflict with the first three?
It is in tension.
Because I feel like modularity tends to give you better security. Modularity tends to give you better interoperability. Reflectivity tends to be lots of people mucking around in what you thought was a well-defined contract.
Yes, there is a tension. That is true. Modularity and security are, in fact, if you go radical on modularity, as Newspeak does, modularity and security are almost the same thing. Interoperability, I think I'm using that in a slightly different sense, in the sense that we want to interoperate with the rest of the world and other languages, which Smalltalk has usually neglected. It's done it poorly, to be honest, and we wanted that to work better. So this isn't
interoperability as in it's easy to write a library in this language. It's interoperability in the I should be able to draw a pixel to the screen or send a packet.
Yeah.
Which typically turns into a foreign function interface, and the foreign function does bad things behind your back. And
now again, foreign function interface is a capability here.
Yeah. Okay.
There's no native or extern or anything like that someone can just throw around, right? It's, again, if you write your module, I can tell you that you are not using the FFI, and you are not using reflection, and you are not using files.
I'm totally on board with that.
Yeah. So reflectivity is definitely in tension with these two. I sort of, in the sense that I'm using interoperability, that one is not. But there definitely is a tension. And as I said, one way to resolve it is because of this capability discipline. If you have the full mirror library, all bets are off. You're back in Smalltalk land. You can do anything to anyone, right? You should not be, how you avoid passing that in is part of the aspect that we haven't done much work on, which is really auditing this and being disciplined, and we really haven't done it. So I'm not claiming the system is remotely secure. It's just that there's an architecture there and a language that lets you.
My goal with the language I'm doing would be to hand out types that discuss things like you do IO or you do foreign functions or not, have the typing system tell you that you do or do not or cannot. Like you say, I want to call this FFI. That shows up in the type of the program as a whole. And so if I hand you a module, the module will include the type that it does an FFI, and therefore your trusted computing base includes the FFI that it's calling.
Have you looked
against that module? Then result now calls this FFI and has that same security limitation or strength or whatever.
Yeah, so that's a very different school of thought. That's the static typing. So effects, they're like Flix actually does something like this. If you've looked at Flix,
I know what Flix is. I mean, I haven't looked at it in depth,
Yeah.
but I've certainly seen it.
Yeah. Now, if anything, my experience in Javaland taught me is that I am not going to trust the type system for anything. And there was the guy which Sun very assiduously removed most references to his work and hired him instead. But the guy who basically used it had a phone and used the KVM to the types in the verifier to break into and essentially the buggy structure of the KVM verifier to break the system completely. So he found the types very useful in actually destroying the security of the system, because there were hints about
that's a bug in the type system. And, for a good 20 years, I could break into any JVM because I knew about the bugs in the type system.
Yeah, and my view is that type systems are hard and tend to be too clever for their own good, and they will have bugs. And that's
I'm not sure you'll get arguments here for type systems are hard.
Yeah,
I'm busy hacking very much extensions to a type system, and I'm certainly having my issues with bugs. So I'll say yes to all of these above. I like them. I'm going to work on it. I think I'll get it right in the end, but I'm still sorting my bugs.
Yeah. So I really prefer to have, it's not that you can't screw up with capabilities, right? Capabilities can leak. Then there are people who do type systems that track capabilities to see that your capabilities didn't leak. And that none of this is necessarily a bad thing. I think real security is a series of hoops, and if you have more hoops, you're more likely to get there. But my heart is, the runtime should be taking care of these things. So essentially, some of these things, the privacy and so forth, manifest in your lookup procedure, in your method lookup, for example.
So how do you think about the interaction between reflection and privacy? If I have a class that has a private field and you're trying to reflect over my class, does it pretend the field doesn't exist? Does it say I have the field, but you're not allowed to look at it?
So it depends on what mirrors you have, right? The reflection is a capability. And you can have, if you have full mirrors, you can do whatever you want. If I want you, for example, to be able to list my public members but not change anything, I give you a mirror that can't change stuff. I give you a mirror that can't access private stuff. You can attenuate anything, right? Now, in reality, we only have the one mirror library, and I've never bothered to attenuate anything, but it's fairly trivial to do that. You just put it in.
So if I make a class encryptor that has a private key and a public method, encrypt and decrypt, can I use the reflection library to be like, hey, encryptor, can I have the key, please?
If you have the full reflection library, sure you can, because you can get all the data, you can get all the slots, you can set them, you can do things, even if the slots. So the language has a concept of immutable slots, but that doesn't mean you can't change them with reflection, right? Reflection means because again, the small dog view of life is this is how you build your system. This is how you write your debugger in the language. You write your IDE, and you can change everything. You can, so it is basically total control. That the deal is to attenuate that so you don't hand that out.
Do you have any ability to say watch or pay attention to what capabilities the modules that you've handed out have, or what changes of them? Like, for instance, could I say I'm gonna keep an eye on this main process, and if it ever gets any path to the reflector module, I'm going to kill the whole program the moment that
the short answer is no. I mean, that's actually not as easy to do as to describe, because dynamically things can flow, right? So you typically construct this by when you instantiate an object, you send in the capabilities. Now, if you somehow have a method that just you decide, okay, here, by the way, I'm handing you dynamically this extra thing, tracking the flow of that, it's an interesting problem.
It requires that requires a God mode. It requires
sure,
it seems like it is a God that has that global overview. Yeah. No,
Well,
but
I
not
think
just
this is where the static stuff may shine, right? This is where you actually track information flow or things like that so that you can statically verify that this is not something you want to happen with effects or something like what, because dynamically this is going to have a lot of overhead. I think if you do implement this, it's just going to cost you a lot. But basically, I have nothing real to say about that. Nothing's been done.
Yeah. Just curious.
Yeah. So let's see, we're at slide 7. So at this point, we can discuss more. I can demo because there are, a lot of slides in the panel.
So, okay, I want to go back and talk about inheritance because like I've looked at inheritance, I've researched it, and like as far as I can tell, it's completely stupid. Like whoever came up with inheritance should be like shot and like hanged and then cut into pieces because it's a terrible idea.
Okay, so we're gonna put Alan down for not liking hereditary rule.
Yes.
Yeah.
So
Yes.
okay, so if you go to the Google Doc, I don't know if you have it open. I think you do.
I do have it actually here. Yeah.
Okay. So like I made this, I made, it's like the second code block down. It's like why
Yeah, why
inheritance
inheritance is broken.
Okay,
Yeah.
so I have 2 examples. And so like, okay. So the first example is you're trying to make an ellipse and a circle, okay? So you define your ellipse, right? It has X and Y in it. And then how do you define your circle class? Well, I mean, you don't know. You can't, I mean, you have to like make a constraint in the constructor or something. But like, it doesn't matter. Whatever you do, it's going to fail because an ellipse with X and Y equal to 1 is not going to be an instance of a circle. It's because it's the parent class and it's not the subclass. So like, the solution is to not use inheritance.
Okay, I'm missing what's wrong with the obvious. The circle extends ellipse and immediately asserts in the constructor that the X and Y that like to make a circle, you have to call the circle constructor, who then will call the ellipse constructor. But the circle constructor immediately asserts that by construction, probably that the dimensions are the same, X and Y are the same, whatever. You have to assume X and Y are major and minor axes.
Right.
So it becomes a radius, and then he passes them both up.
The issue is that you have ellipses which look like circles, but aren't actually instances of the circle class.
That's correct. That would be a different problem. That I see what you're saying. You're saying
right,
some ellipses behave like a circles, but aren't a circle class.
Right. And so if you instead define it as a refinement type, you say that a circle is an ellipse where the major and minor axes are equal, where x.x equals .y. And then you don't have to worry about inheritance at all. And any ellipse whose major and minor axes are equal is automatically a circle. So there you go.
Yeah, I'm not seeing the large gain yet in this particular example.
Well,
I'm all
I'm
happy.
not seeing the benefit outside of an argument in a university class.
Yeah,
in this particular case, inheritance is completely useless. Like you don't want to use inheritance.
No, that's not
That
true.
is not the reason why you use inheritance, right? I mean, you use inheritance because you want to reuse some existing functionality and you want to extend it in some subclass.
Yeah, you got the area computation for an ellipse and the circumference and all that kind of shit. That'll work just fine for the axes for a circle, and you can inherit all that.
Okay, well, that's where I have my second example. My second example, okay? You've written a list class, okay? And it has an add method and it has an add all method. Okay, and the add method adds one object at a time, and the add all method adds like a list or an array of objects. Okay,
yeah. And then you have a counting guy.
Yeah, you want to write a counting list that tracks the number of objects in the list. Maybe it's a linked list, and so it's expensive to compute the number of objects in the list, and so you want to store that in a separate field. So then, okay. So with inheritance, obviously you say that the counting list extends the list. And so you have your num objects field, of course, and the add method is really easy. You just say, increment the number of objects and, call the super add method.
Yeah.
But what about the add all method? it turns out you can't call the list add all method because you don't know if it uses the add method of the list class. And in particular, the way inheritance works is that if add all calls the add method, it will call counting list.add instead of list.add.
Right. Yeah, I agree. That one's busted.
So that's an implementation detail. If it does call the add method, then it will increment the number of objects, and you don't do anything to the counter in the add all method of the counting list class. But if it doesn't call the add all method, then you have to increment the counter yourself. And so because you don't know this implementation detail of the parent class, you have to do it the slow way and just call the add method that you are pretty sure doesn't call any other superclass methods.
Just store a number of objects before you call super add all into a local variable and test it afterwards. If it doesn't increase,
No,
just do it. There you go.
Well,
shoot this man.
Okay.
No,
So
you
There
claim
is
that
something actually very close to what Chris said, which is you take the size, you call the super add all, and then you adjust the size to what it should be after the add all.
Right,
Yes, because
So
you
that's
are
like
the
saying
subclass, you are the counting list, you are responsible for the count, because that's, I mean, it's a stupid example, but if you want to implement the counting list, then your methods have to handle the count.
Well, I mean, the place that doesn't work is if you have things that you can't undo, like if it prints something to the console. You can't just say, oh, it printed something to the console, let's undo that and overwrite it with.
Let me add another constraint here.
The challenge, I was just going to say that the challenge of Alan's examples is it's like we don't live in a universe devoid of subclassing. And strangely enough, it does work, right? Like we have a billion examples of actual working apps.
So let me throw another one out here because
well, no. I mean, I just want to go through the last part, which is that with composition, it works perfectly. You just define a list super, and then you can call super.addAll and increment the number of objects, and it works perfectly. There's nothing. There's no problem.
This example works better with composition versus inheritance. I'll agree.
Right. And so the question is there any example where inheritance works better than composition?
Oh, I use it all the time.
I mean, isn't the composition thing not pretty much nesting in the sense of self or beta or Newspeak?
Right. But the point is, it doesn't have this stupid virtual dispatch thing that Gilad was saying he likes so much. So like, you just don't have virtual dispatch, you don't have inheritance, and then your programming language works so much better.
I have in my core implementation of AA a node class, which is a compiler IR. Nodes have very little data structure, and they have 50, 70, 100 functions on them, that tiny thing with a lot of functions. And then I have a very bushy subclass. I have 50 subclasses that do minor incremental changes off of a very common parent. And the virtual dispatch thing is exactly what I want. Now, the difference here, I think, between your counting list and what I'm doing with nodes is that I'm willing to have my subclasses know the internal structure of the parent. An add node knows very well what a node will do with edges and result types and things like that.
Yeah, but the question is, I mean, is there any data in the node class that you actually that needs to be inherited? Like, what could you just make a node data type and have all your subclasses?
I'm inheriting the virtual calls so that I can, so I don't have to have re-implementation, and I can skip having an extra layer of indirection.
So you're saying there's no data in the node type, and it's all data in
there's definitely data in the node types. Node types have outgoing pointers to other nodes. It's a compiler IR. You get a directed graph.
Okay.
They have counts of nodes, and they have a collection of nodes going out, a collection of nodes from the def use and the use def edges. They have internal type values during analyses. What is the Hindley-Milner type? What is the flow type? Kinds of things. I'd have to go look now. There's liveness. There's a handful of other, but these are all analyses types.
All right.
That are common for everybody.
So, I mean, the question is, could you replace it with an algebraic data type where like all of the subclasses are tags on an out of the variance of a value, and then the node class is
Well, they
these
all
things,
have different
and
functionality for different things. So when I make a subclass, I usually have to implement 5 or 8 abstract calls. Like, what is the flow analysis, the glorified constant propagation, if you will. So that varies from add, from divide, from multiply, from load and store. All these things have different flow analyses. Same for Hindley-Milner. Those are all different for every subclass. So they get abstracted in the parent, and every subclass has to do something there.
well, if you only
So I
have like
can-
8 methods,
can-
then an algebraic data type will work. You'll just write, you'll write a method that does case over all the different data types.
Right. I'm not. Yeah. Okay. So it's not that I'm claiming that they will or won't work. I can clearly write it in a different way. In much of my cases, I'd rather have the concept of an add and an add node and an IR be held together as a WAD. And here's the things an add does. There's a 90-degree orthogonal version of that which says, and here's what I want to do when I want to compute the forward flow propagation type. If you're an add, you're doing this. If you're multiply, you're doing that. And then I have this switch or enum or whatever, which for the functionality of doing forward flow propagation, here are my 50 bushy subchildren. That's another way. But I also have the same problem for the liveness. I have the same problem for the Hindley-Milner. I have the same problem for the fancy print. And I have the same problem. So I get a dozen of these things that are a giant switch statement, if you will, a giant enum, and they implement this functionality. So when I add a new node, I have to go and add a line in each one of these 50 places to go. I mean, this is the M by N problem that I'm doing with inheritance because my problem is structured this way.
So, my implementation of sea of nodes is exactly what you just described, Cliff. I'm the 90-degree rotated version. I have my nodes are a simple data struct. They get stuck into a graph node, which is a dumb graph node. You have type, you can pattern match against it and stuff. And all of my reduce functionality for every kind of node is in one file. All my grow functionalities in one file. All my divide it up that way.
Yeah, I actually went down that path a long time ago and decided it was easier done with nodes and inheritance than. But wait until you get a bigger setup going and see if you like it 90 degrees the other way or not. And maybe it's just a matter of personal preference on this way. You go left or you go right or whatever. You go this or you go this. Maybe it works both ways.
So I don't necessarily want to get bogged down into this particular religious argument. I did think, there's a point of view that says there's a tension between inheritance and modularity, and and there's a point of view that says that it enhances modularity because there's a bit of both to those. And modularity was my chief concern. Is everyone familiar with the expression problem?
Yes. Well,
I discussed
most of us are.
On this thing like a year ago, I think. I don't know how many people remember it.
Feel free to give a few sentences for the YouTube audience, though.
Oh yeah.
Okay, so I'll give you more than 2 sentences because there are backup
you're a generous
slides.
guy.
The expression problem is essentially a situation. It's an example of a much broader phenomenon, which is basically goes to this tension between extending in different dimensions how you evolve your software. So the classic example is you've got a very simple language. Here we have it. It's an expression is either a number or the sum of 2 expressions, right? And we can express that, in this language, build an AST for it right here. And if that's hopefully large enough for people to see, otherwise.
Oh yeah, totally. Yeah.
And so, what do we have? We have 2 kinds of ASTs that actually, 2 kinds of tree that correspond to these two branches of this thing. And there's probably not much in these ASTs. Essentially, they just contain the data, right? So you can construct a number and you put an actual integer or floating point thing inside. and you can look at a sum, and a sum has two sub-expressions, E1 and E2, right? So that's just a pure AST. It has no functionality, whatever. And then let me get rid of the slide list. It'll be a bit bigger. Then the question is, okay, you want to extend this in different dimensions. First of all, consider the fact that you probably, you might want to do something with it, like write an evaluator, right? So here's an evaluator, that's a separate thing. And it's written here using class hierarchy inheritance because it's actually a useful way of letting you both add new types, like new things that are new kinds of expressions, like products or something like that. And on the other hand, you want to add new functionality like evaluation or pretty printing or whatever. So these are sort of two dimensions in a table, right? And initially, we write this evaluator for this particular language. And an evaluator will have, essentially, we want to extend the notion of numbers with how they get evaluated, right? So you could, of course, write a function, which is probably what I'm guessing you'd advocate. If you don't have inheritance, that's what you do. In fact, even if you do, anyway, let me try and make this more coherent. There's an evaluation function. And in the case of the number, it's really trivial because it's holding its value inside and it just has to return it, right? That's the val right here.
And the caret as a return.
Yeah, caret is a return. Yeah, I'm sorry, I'm not going
with
through
you
all
on
this.
that one. That's my choice for return.
Well, that goes back to 1976 or so.
76.
Right. Actually, the alto had a character that was more of an up arrow kind of thing.
Oh, yeah. Holy crap.
And that's what they used.
Yeah. Okay. Fine. Yeah. I forgot.
And then they
You'll
got
occasionally
ASCII
see
land
that.
and they were
You'll
stranded.
occasionally see that in old textbooks, the up arrow being used as a return.
Yeah.
Is that an alcohol thing or?
No, alto.
That was on the alto, I believe, on the alto keyboard. Yeah.
I got to use one summer at Xerox Labs, whatever, summer school for high schoolers who were accelerators.
So this year is the 50-year anniversary of the earliest version of the alto, I believe, and they're going to do something at the Computer History Museum this year, or maybe 2023 actually. So it's upcoming. So yeah, you can go to the Computer History Museum and see an alto.
Play with it. I did 50 years ago.
So anyway, they got stranded in ASCII land, and now we have Unicode, and we could actually try and civilize this again, but that's a whole other argument. Anyway, the point is, you want to both, the point of the expression problem is that you want to both add new functionality, like extend this language with evaluators and pretty printers and what have you. And on the other hand, you want to extend the language in the sense of now there's going to be products and sums, and you want to make all those extensions separately, modular, right? And this is something we use inheritance for. We use class hierarchy inheritance for, because one of the classic things with an AST is one of the classic mistakes in object-oriented ASTs is people write an AST and then they shove all the functionality into it. And then eventually it gets out of hand and too big and clunky, and they realize that their AST should be pure data and they should have something external, and they get into visitors and all these things, right? So one of the results of being able to use class hierarchy inheritance is we don't need visitors because we can actually put each of these things in its own rubric. So let me actually...
And by the way, you didn't mention it, but this looks like you were demoing a live coding example from your...
Yeah, of course. Yeah, it's all live. It's all embedded in the slides. That's kind of the stuff that has implications for all of this too. But let's go back to our presentation. So I could right. This is, I can open these classes. I can do things to them. I can modify them here. The whole thing is completely live. But actually, I wanted to go somewhere. We have a slide with the right. So I've said this, you want to add multiplication. You want to extend the evaluator that you wrote that only evaluated for sums. You want to add the part that multiplies, and you want to do that separately. And you can't, of course, touch your old source code, and you cannot use a visitor. So how do you do this was kind of the point of this. And just zooming through this, you want to basically do all these things. So you get this table, right? You have functionality like pretty printers and evaluators, and you have numbers and sums, and eventually you're going to add like products, which is a new row in the table, but maybe you add a type checker, and that's a new column in the table. And you want every square in this table to potentially be written independently of the others. And that is what part of the solution here is something that inheritance gives you, is the ability to extend these modules by basically taking an existing thing and extending it, or if necessary, modifying it independently. And this corresponds to a cognitive structure, which people have, which is like analogy. I have a thing, and this is just like that, except something. And it's a very fundamental point, which I think is the key to why this works for so many people, despite the examples that may be awkward or maybe problematic, or, you know, the tension, the fact that it exposes an interface that's broader than maybe you like, because part of that interface is its internal structure or parts of its internal dependencies that you need to know about to use it. But it has great utility because it corresponds to that pattern, and it actually lets you do things in a modular fashion, which, you know, is pretty hard to do in most languages. So we can do that by defining these things, and one could go blow by blow into those examples. I just wanted to show this. There's another point I wanted to make, because at one point you made the comment that all this virtual dispatch thing it should be thrown out. So I'll point out that virtual dispatch and inheritance are independent. You can have virtual dispatch or dynamic binding, as it were, without inheritance. And dynamic binding is actually the more important thing. So the point of, and again, some people don't believe any of this, but the point to me of object-oriented programming, the main point, is this idea of interfaces. You have something that has a set of operations, and that is your interface. And you can have different implementations of this set of operations, and you don't have to rewrite your code because you're statically to use these different implementations, because you're not statically bound to them. None of this has to do with inheritance. If you didn't have inheritance, you could write a separate implementation of like a stack or whatever example you want. And there's some code that can use a stack with either implementation or any number of implementations. And that's what dynamic binding is essentially about, right? The use of interfaces. And you don't get away from the use of interfaces no matter what you do. You can be a dyed-in-the-wool religious functional programmer. You still have interfaces because your modules are interfaces. Your binaries are, you know, essentially libraries are interfaces, right? They may not be first-class things that you can pass around so easily, and so they're not objects, but they're like objects in the sense that they're a record with a collection of functions in them that you can invoke. So I think those things are pretty fundamental, and that's kind of what drives my view on these things.
It's certainly the way Barbara Liskov used to talk about it. Liskov would say, if you want to know if A is a subclass of B, can you replace the A with a B? If yes, it's a subclass. If no, then it's not.
Right. So the principle of substitutability, of course, that's easier said than done, because actually proving this and verifying this. So pragmatically, the systems are such that, yes, you can abuse them in all kinds of ways, and no one can protect you from modeling errors that you might make in certain cases. And sometimes you want to just, some people say, oh, using it just for implementation to save the trouble is bad style. Well, you know, you can get more or less religious. But I think that overall, I decided that it had a lot of utility, and I wanted to keep it. In fact, because I had this dynamic binding, I got more utility because I could do whole hierarchies, which are utilized here in these examples for the expression problem, where I can override the AST classes that themselves are nested inside some larger module. So there's, you know, you can certainly design interesting languages without it, but I basically.
So how does that affect the structuring of code?
Sorry?
Often in these sort of n by n problems, it's like, okay, either I can have classes where if I add a new function, I have to add that function to all of these different classes.
Right.
Or I say I have a bunch of different functions that can take a bunch of different types. And if I add one more type, now I have to go update all of the functions.
Yeah, there'll be a type case inside these functions, and you're going to have that's the essence. Thank you. That's a very concise way of essentially the expression problem. Is right. Can you work across both these dimensions without having to go and modify the original code, like going inside the function and adding a new case, or going inside the class and adding a new method, right? And inheritance is part of that, because now you can add these things to them from the outside, right? You don't have to fiddle with this code. So that's kind of my response to this whole debate, and it's a religious debate, and therefore is unlikely to be resolved. But I did want to kind of get to that.
So I have one more observation, though, which is that there's something called multiple dispatch, and so multiple dispatch conclusively shows that the functional view is superior to the object view, because there's only one function, eval and pretty.
There's no such thing.
But if you have, like, say, for example, a comparison operator less than, then it has two arguments, and you want to compare objects of different subclasses, and so you'll need twice as many you'll need the square of the number of cases for your objects.
Like in all these arguments here, the thing that I hear routinely skipped over is the cost model, time. You only have one life to live, and when it's over, it's over. And if I spend all my time on languages that are 1,000 times slower than other languages, it changes what I can do with my life. And so I would like to make sure there is an efficient implementation possible for a lot of these kinds of constructs, which many of them there are, but not everywhere.
Just to be clear, though, multiple dispatch is not multiple dispatch. There is only one real implementation of multiple dispatch, and it's actually two parameter dispatch, not multiple. It's always two, and it's always it's only exists to implement binary operators in a particular language. It's a joke. I mean, it's not a concept that gets reused where there's some n which is 1 or 0 or greater. N is always 2.
You're talking about Julia?
So, whichever crappy thing it is, yeah.
Yeah, right. Okay. So I hear multiple dispatch. I saw it come around in other languages. It never had a good implementation. It turned into, for me at least, it turned into very confusing rules on who got called. And so it's just bad for confusion and bad for performance.
And what it did was even worse than the two previous examples, because I love functional programming and I love object-oriented programming, and I'm happy to go change all my cases and I'm happy to go change all my classes. But what I'm not happy to do is deal with multiple dispatch, where it's like I have this sparse, now I've added one more dimension to the problem we already had. So I went from a two-dimensional problem with an axis of functions and an axis of types. Now I have a three-dimensional problem with an axis of function, an axis of types, and introduce a new z-axis.
Which is types, but it's
type combinations.
It's the first argument instead of this pointer. Yeah, right. Oh yeah. Yeah, the problem became cubic.
So combinations go up. Yeah, quadratic at least. I don't know. I'm not a mathematician.
Yeah, that's ugly. Fine.
Yeah, so I'm not a fan of multiple dispatch myself, because of essentially the thing that you change something and now your old calls don't call the same thing anymore. It's sort of it helps modularity in one dimension and hurts it in another, right? You can add these things, but then so you can come up with examples that work for everything, but definitely too complicated, too slow, too confusing. I don't like it. But again,
I really wanted to love multiple dispatch, but I could only find this one language doing it, and it was only doing it to make the language developer's life easier. And it's like, if there's anyone's life who should be harder, it's the language developer, because he gets to write it once. Everyone else downstream, their life should be easier. And that's, anyway.
This is like, well, fine. R back in the day did it, because I think they just didn't know better. They were learning. But I think Julia did it on purpose, which I think, turns into, I've talked to a large Julia project before where they went hog wild on it, and God, it got ugly fast. Never mind. Okay, I had a different angle that came up from Alan's comment, and that's the necessity or the thinking, at least think about bulk interfaces. The difference between the one-off add to a collection and the bulk interface add all is that you can play in the bulk game performance gains that are often orders of magnitude greater, and that quantitatively changes the kinds of problems you can sort or solve. I'm going to sort out, figure out. So the decision to have a collection and you add one, if you do that, you must have an add all or a bulk add, and the bulk add has to carry the performance guarantee through the layers of the hierarchy in your collections classes to wherever the base case is. And if you fail to do that, you fail to have a reasonable cost model, which turns into, I work great when I'm testing on my desktop for 1, 2, 10 things, and I put it in production and I had 1,000 million billion things, and suddenly it fell over. And then I'm hand rolling a different kind of collection because the existing collection can't handle me adding 1 billion things. And sorry, that's me, but I find with this all the time, you forgot how to make the bulk case go well and preserve your knowledge through the bulk case.
I think for design of let's say interfaces for such collection interfaces, I think it's reasonable to make a requirement that the methods that are exposed for overriding in subclasses should not have hidden dependencies between them, exactly to avoid these issues Alan mentioned. I think it's a classic example from the Java puzzlers Alan got it from. But I think the interesting question is, can we actually make the compiler check that, okay, you have this set of methods that are supposed to be implemented by subclasses, but your add all method uses add internally, which is also meant for overriding. Shouldn't you instead use some kind of add impl method that's private and not subject to overriding?
Yeah, this is all modeling questions, right? It is hard to decide. I mean, beta, for example, goes and tells you that you essentially inheritance works, but you always have to call inner, and so the original class, the top of the hierarchy is in control, and you can add something in the middle that you would like to do as well, but you can't stop the higher levels from doing their thing.
That was actually a question I wanted to ask. I mean, we see that beta has has basically the opposite approach from classic languages using super calls, and I think from my perspective, it feels it's a valid design. Do you have experience of that, and what does Newspeak use? Super or inner?
Okay, so my experience with beta is very limited, though. I spent a lot of time with people who had tons of experience with beta and implemented beta and so forth. And a long time ago, I guess by now it's over 30 years, I co-wrote a paper where we showed that if you if you use mixins, you can implement either beta style inner inheritance or classic style super inheritance. They're sort of inversions of how you order the mixins. And in principle, I guess you could do that in Newspeak, but Newspeak basically does the classical Smalltalk thing with super. It gives you more flexibility because I think my interests are flexibility and modularity, and the trade-offs I make are sort of in favor of that. So we haven't emphasized that aspect.
Can you give me an example of more flexibility?
Well, the whole expression problem thing is one example of both modularity and flexibility. But I also mean like the reflective thing, right? The fact that I can do these nifty things like live changes and things, which is another thing I thought would be interesting to talk about because it hits your implementation in various ways. Like you have to be able to accommodate the fact that, at least potentially someone will come off and can change things, and you have to deal with things like reshaping all the instances, all that magic that Smalltalk does that no one else really supports properly, which I think is just a blind spot of the whole programming language community for many years, to enable you to create these live systems, which essentially this translates to instant feedback on things, right? Yeah. So let me try and
we talked about at Azul. We talked about whole heap object reshaping, but as an optimization strategy, not as a user visible thing. Like you look at any large running Java system with 1,000 classes and however millions of objects, some large fraction of fields are always 0, nil. And the optimization is to simply don't put the nil in the object, shrink the object, and if you're only reading the field, the JIT just hands you the 0 because he knows. If you ever set that field, then you have to rejet the code and you have to inflate a bunch of objects. And can that be done efficiently and well? And it turns out that you can do it with an Azul style collector, the read bearer style collector. You can go efficiently remap the objects, but it's a big engineering project. The gain for us was performance. You shrink all your objects, and they both cost less bandwidth to build and they less cache space to manipulate and field adjacencies and better locality and yada yada performance.
That's fascinating. That's really because I've never heard of that angle on it, but it's the same machinery, right? It's very much the machinery that your garbage collector has. I mean, there are other ways of doing it. You can do it lazily. But generally there's trade-off
lazily because the garbage collector was lazy.
Yeah. But the thing is that it really for me is because I want this environment where I can change things like live on the fly. Yeah. And let's see, maybe we can demo something because this so we can go here and yeah, let's try and look at a workspace here. And okay, I need to move you guys because you're blocking part of my menu. So you're going to the other monitor, which means that I may look sideways when I talk to you, but that's okay. Let's see. So
but you have to explain what make adult button means.
Oh, make it do it. Is,
oh, I like dolt better.
Okay, yeah. So this is we need better fonts.
I got it now.
Yeah. Let's say okay. So this is an old demo that I used to do in the Strongtalk days. But let's do this. And now I've got a list, and in the scope of the list, right? So speaking of adding to list, let's say I want to add something to the list. So now it's got 3 in it. And now I go and select this thing and make a do it button. And now I have this button that adds 3 to the list. I mean, that's a sort of simple demo.
Nice. Okay.
Yeah, so that's what make it do it. It probably shouldn't be there in the sense that this isn't necessarily the right or general way to have this functionality, but it's great for demos, and I left it there for now.
Yeah.
But more generally, there
I'm used to the Python notebooks that just say play.
Sorry?
Yeah. Python notebooks have a play button that replays the script.
Sure. Yeah. So well, there's lots of things you can do. Believe me, anything a Python notebook can do, Smalltalk can do better. But it's just the point of the interactivity. But what I really wanted to do here is, let's see, this is an object presenter, so that's probably good. So what that menu does is we're now looking at the widget that the actual object that was implementing the GUI that we were looking just before. It's an object presenter that was presenting that list. And one of the nice things is I can look at the class object presenter here in the context of a particular instance. And then I can evaluate things like methods here that actually, I can evaluate this right now, and it will, there is a bug about scrolling, but basically, so I can actually evaluate this method, and it turned out to be an array, which I can then inspect. And I can change things, right? I can go and let's see, what would we change here?
We'll make a do nothing button. Add a do nothing button.
Oh, to the
Yeah.
to the menu. Yeah, I can probably do that. Let's see. Do nothing. Right, and it's not gonna do anything, I guess. Yeah, that should do it. And this was the menu. This is, which menu did I change? Let's see. This one. Yeah. So yeah, that's here. Let's do it again in case of it. So yes, we do have do nothing in the menu now. We click on it and it does nothing.
Actions menu. It's not in the list below the actions menu. Gotcha.
But that's this was the method we happened to edit. The main point, yes, we changed it. We changed the ID live on the fly from within itself.
Yeah.
Right.
Yep. Yeah. It was always a small talk magic thing that back in the day was like, holy fuck, that's magic.
Well, it was magic back in the day, and the fact is that most systems can't do it to this day. And there's utility for this for, it's an addictive kind of way of having, a development environment where you can change your program and do all these things while you're, very, very easily and so forth. But it's also good for end user programming, for all kinds of things. So
when do you pickle such changes in so that the next time you restart the system, you get that kind of a change?
So yeah, so there's different ways of doing that. The classic Smalltalk way, which is interesting probably to discuss, is their notion of an image or a snapshot. So literally you have a format which captures the heap, and you save that to a file. And if it's done right, you can take that file and restart it 6 months later on a different machine, on a different operating system, and you will be back exactly where you were, down to where the cursor was and what was highlighted, right? That's what classic Smalltalks do. So there are upsides and downsides to that.
Okay, I was going to say, isn't there an issue there where you break something stupidly, you can't remember your way back, and you pickle an image that's broken?
Yeah, there is an issue there, and so different ways. This is one of the reasons that at the moment we don't have an image here, because we didn't want to. The Smalltalkers get very married to the image. Yeah, and it's great. It's really nifty, but yes, there is that sort of problem that if you corrupt your image, okay, it's awkward to start again from, there are many issues there.
I would often call this it's always in the context for me of like performance analysis. I worked for a while on some problem, some script to go build a setup going in whatever language, R, Python, and I got a performance number out. Now I want to script myself so I can rerun this performance test over and over and over again. It turns out I changed all these files out in the OS, and I changed what was running on my machine. I changed versions or whatever, and I can't get back to where I was when I got performance number 6 months ago because I didn't capture enough state.
Yeah, so the image is actually very good for that sort of thing, right? Yeah. It's fantastic because you can, if you're going to give a demo or if you're going to start up and whatever, you can be sure we're exactly where we left it. It's exactly the same thing. Now, the downside is you also described that if you screw something up, you're exactly where you were screwed, and it's not so easy to do that. One of the problems with Smalltalk is it's relatively awkward to get the program out of this image, just the program, just the code. And Newspeak deals with this because Newspeak actually does have a proper, a conventional syntax, and you can put it into files and save it to files and put it into Git without. The classic Smalltalk system just didn't address this. Basically, if you wanted to save code, it had this, it still has many of them, this thing called file out format. And that thing would tell you when the thing was filed out. So it had a lot of extraneous information, which made it very hard to put into source control because the same class would, if you filed it out on Monday, it had a different date stamp on it and various issues that made this very hard to work with. So
I've even had that problem with closure, that I'm building something up in the interpreter and I finally get it working, and then it's the question of like, wait, what did I do? I need to go back and get that
Yeah.
into the source code.
What you typed in the interpreter is now.
And I'm like reading the
script.
interpreter history to try and figure out.
Right. So there's this trade-off, right? The nice thing about the image, your workspaces are there. Workspaces are basically much better than repls, because repls were a great idea in 1965 or whenever. But the idea that no one has made any progress, in fact, people have regressed on them. Repls in a lot of systems today do less than repls did in BASIC back in the day, right? Because a Python REPL isn't suited to do program development, right? It's suited to compute things, but you want to put in anything longer than a line, it starts to be awkward. And where's the history and so forth? So it really isn't built for that. At least back in the day, the old APLs and basics, they had this system where you actually could, put in lines and they had line numbers, and you actually could develop your program in these REPLs. So in some sense, REPLs today work less. And don't get me started on the functional language REPLs, which are even worse, because
I'll keep that in mind.
they take a principled approach with again, the principles tend to be mathematical and not sort of cognizant of human thought processes. So the classic ML REPL, when as far as I know, this is still the case even in F#, which was a big step forward for those guys, and it's still the case in OCaml and all these things, is that when you redefine something, you're not redefining it. It's all modeled as if it was a nested let. So you had a function that was buggy. You have F, which calls G, and G's buggy. Now you redefine G to fix the bug. But yeah, there is no dynamic rebinding. It's all right. This new G is in a nested let and has nothing to do with the G that F was calling, and so F is still broken, right? Which completely obviates the whole point of to me of the REPL as a development tool, not just a tool to demo something little or to play with, right? So Python REPLs are okay in that respect, but they really aren't designed to let you do development or leave a piece of code hanging, right? The nice thing about like a workspace is, you can have different things here, like platform JS, right? Or something like that, some other expression, right? So this will actually give us the module that deals with the FFI to JavaScript, right? Which is, again, a distinct object and a distinct capability. And so global at whatever, I think, let's say just object, because I'm sure that's there, right? So I can ask this and I can get this thing, which is a JavaScript object. I guess I type twice, and then I can browse it, and it's actually giving me a view of a JavaScript, prototype. Right. Yeah, because we're running on top of the web here, so that's just another little demo. But the point is that we what was the point? I don't know what the point was. Sorry,
the point was you're trying to show is that if I update, if F calls G and I update G, that was a different point. No, the point here was actually just that the workspace lets me have, I can paste in different pieces of code and they're there. It isn't this thing that scrolls by and I can't get back to it, because now I can reevaluate these things. I can come back to here and say, okay, now I have my list back. And of course, it's more interesting with a more interesting piece of code. But the fact is that the workspace is different from a REPL, because a REPL was designed around teletypes, right? It is literally throwing that in the links. There was a chat from Matt that's useful. I should go in the links here. It's fine.
So yeah, anyway, all of these are, I guess this is what you want to do here, is a million tangents on different topics. But yeah, I think the image helps with this too, because once you have these workspaces with these little things that you played with, when you save the image, then of course that's still there and you can come back to it and what have you. But even in a single session, a conventional REPL doesn't make it easy for you. And people invent things like, oh, give me the last line, or they're weird. I've seen REPLs with weird syntaxes that let you kind of index into the history of
that would be the shell. every shell REPL on the planet has a bang history number that you can pull things out of. But I'm
Yeah,
not claiming that's a good design. I'm just saying if you're a teletype, it's a better teletype.
Yeah, so it all goes back to teletypes, right? And if you just, I mean, I used to use back when I used Emacs a lot, right? You put a shell, at least if you put a shell in an Emacs buffer, then again you have this property that you can go back and cut and paste and find these pieces and evaluate them. So it's just that it's a shame that the teletype lives forever.
I mean, just to cut in with a language that is maybe unexpected in this setting, but I have actually seen this done pretty successfully in C++, where you have in game development people modifying C++ code of the running game with a very low latency recompilation, and you can change what the game is doing while the game is running. And for debugging, we can actually even step back and forth. So we have an undo feature and the redo feature in the integrated development environment. And you can even step back and forth between different versions of the code, and the game still keeps running while you're doing this.
Oh,
what toolchain and IDE was that?
It's actually, they integrated this in Visual C++, but they say it's actually independent. They can also do this on different IDEs. So I posted a couple of links with the videos with demonstrations. But it's really cool. It's actually smart about what it's recompiling. It's actually only recompiling what needs to be recompiled. So that's why it's actually pretty low latency. So it allows for this to work in practice.
Well, the question to me was the semantics of flipping between versions, and you're not cutting in the middle of one, like someone.
Yeah, it's a hot reload. It is hot reload. So it's recompiling the dependencies and it's hot reloading them on the stack. So it's
the next method call to that function, you get whichever version.
Yeah, and it's pretty impressive for a C++. I mean, this is not the language you would imagine.
Doing something like this being done is really hard, and I don't know quite where they hit the limitation. So there's several topics there. There's the sort of the time traveling debuggers, which is something that's on my list, but doesn't work.
Incredibly slow once you get past a certain point, but in the tiny scope, it was fun. But
so it's really hard to make them work well, right? Because it's enormous amounts of data that get, there's various issues. So time traveling debuggers are still, I think, they're less. I think they're fantastic, but they're less actionable perhaps for a lot of people.
To my understanding, the most popular one is using the hardware performance counters to vastly limit the amount of data it needs to record. So it basically takes the snapshot of the state, but only very limited subset. So overall, it has 2x overhead, which is, if you think about it, twice as slow is not so bad. I mean, it's already on par on, say, running address sanitizer. So I know that they were able to use this for Mozilla Firefox.
Right. So I actually, Splash is ongoing or ending today. And just yesterday, the guy gave a talk about RR and his subsequent work with Pernusco and so forth.
To Matt, I'm asking Matt to put a link in.
I can find a link and eventually stick something into his work, right? So there is that. There is changing code on the fly. So there's a whole problem of, like, depending on the system, how it's organized and how much you optimized it. If you optimize it a lot, it becomes harder to unravel these things, and you have more work to do to do this. So these systems are typically organized so that, the whole programming interface, right? If we go to, let's find a class that we can show, right? The interface, okay, let's try, what does Workspace have? Yeah, this is some examples, right? The interface is designed to let you compile method by method, right? So it's not trying to make the compiler super fast. So this is the exact opposite of sort of the approach that Anders Helsberg used to take, which is saying, I'll make the compiler so fast that it won't matter. It'll just compile 100,000 lines a second, and it won't matter, right? The thing is, eventually you get to a place like Google where the code base is so big that nothing you'll do will ever help. It will be too big to get interactive response. The alternative is when you have an architecture where it really is designed for incrementally compiling little pieces, and you know, you never, even though compiler is actually dead slow, it doesn't matter because you're compiling a single method at a time. And once you compile that, you stick it into a method table, and because everything's late bound, that does mean you have to de-optimize and all that kind of stuff. But and so you have to facilitate this. You have to have a system that's capable of doing all those things, which has implications for implementation. When you deploy it, okay, for example, in Newspeak, you can know that, you know what, I didn't actually use mirrors here because I didn't send them in. And and I can start optimizing on the assumption that there won't be reflection, right? Because I actually know that. Unlike, say, Java, where it's you have to do a bit more analysis to find out whether that really happened. But the support for interaction, it's a very addictive development model, and it also lets you do all kinds of nifty things, not only in development. I've got this editor. Let's see if I can find it. Oh, well, actually, what happened? We were here, right? Where's our history? Well, actually, let's look at our presentation, which was which one was it here?
We were coffee and compilers.
Yeah, that's you guys. Yeah, right. So here I can play games here, I suppose. So I'm gonna, yeah, okay, that's interesting, but I should be able to do something like this. Will give me a message not understood, right? But if now I can go and so the point is, each slide here is actually an object. It's a document that is an object that is being viewed through this kind of editor, which is another one of my pet peeves, right? The fact that I can change slides while I'm presenting them, right? It's modeless. There is no presentation mode where I'm stuck and I can't touch things. But one of the things, I can go and inspect the underlying document, and I can look at its class. And okay, I'll add a method foo here. And I'll do, this is one of my standard demos. I'll have a button here. I'll call it foo, and it will have an action to say, bring up an alert. And the alert will say, hi, right? Something.
Yeah.
Now we have a button here, right? Where we had a message not understood before, because we just changed this. So the idea was, I type in text into this thing, and I select it, and I can basically convert this into a widget that is the result of a method that I'm calling, and the method that I call is given by the text that I put in. I said that too fast. I typed in some text like foo. Foo is the name of a method in the document object. That method is supposed to return me a live widget. And so when I select it, I go call this method, get the widget, insert it into the DOM, and now I have a live widget in the DOM. So I actually have a GUI builder right here where I can type arbitrary things, and this is live, and it does its thing, right? And so all these slides, this is how these slides are done. This is why I actually have a class presenter live inside the slide, because it's the same thing. It's actually using this guy. It's probably one of these methods, I guess, is probably either graph module or graph subject or something like that. Is this calls that, this calls this. Yeah, this one, graph module. That's the method that, returns this guy, right? So I get this presentation of a class that I want. So I can actually do the interactive slides this way, but I can also build arbitrary GUIs or extend, I can have an editor where I can add functionality or do live things with it. And it's relying on the fact that, yeah, I can change the methods on the fly. It's all reactive and dynamic in that way. And I think it's just a more fun way to use a computer. Not only for it's even for sort of very low code development where I want just to throw something together. So that's another aspect, but that means, yes, you have to be willing to support all this de-optimization and all these things so that you can actually do that stuff, which I don't think it means that necessarily things are slower. It means that you have to do a lot more work to make them
it work. Yeah. Yep.
So, so if you wanted to divorce your implementation of this slide thing from the runtime image, how is there some kind of text-based serialization format where you can say, okay, I can read through this code and it's reasonably pretty, or is this like some binary or some
there's
ugly?
different ways of doing it, and this is some of this, like the presentation manager that you're seeing is pretty new. I did it for a presentation last month. I finally said I'm fed up with tools that won't let me do this. Like if I use PowerPoint or Keynote, I cannot stick a live widget inside in my presentation, right? And it just will not do that. And I could write HTML by hand since the system is running on the web, but I wanted an editor. So I finished this on the plane to Argentina a few hours before the talk that I was giving with this system. And so lots of things are incomplete, but basically you can save a slide or a document right here, and it will save an HTML file. The HTML file has the source code for the document class that has these functions that you're relying on. And so we can save it and then read it and put it back together again with caveats. For example, if that code has external dependencies that I was referencing, then if they're not in the running system, then it will complain because they're not there. It would actually be better to save it as a binary thing, which was a binary serialization of everything put together. So it would be, completely reliable to go back, but then you can read it, right? So there's trade-offs, and I'll probably end up supporting both. Are we there yet?
Yeah.
Oh, well, I was just wondering, so there's this thing called the Jupyter notebook interface.
Yeah, sure. Yeah, there is such a thing. Yeah.
I don't know. I mean, obviously, it's compared to your system, they have strengths and weaknesses, and I don't know.
Yeah.
I was just wondering if you had, if you were going to do it over again, would you use the Jupyter interface?
I am going to do it. Oh no, the other way around. I would not use the Jupyter notebook for anything. What I have on my list is to build something like Jupyter Notebook. Okay. Now I don't. This is more because I know some guys who use computational notebooks who are interested in more flexibility. Once you have this fully working and debugged, a Jupyter Notebook is a fairly easy exercise, right? The only thing that you have to add is it has these reactive dependencies between the cells. So you need to actually have an implementation of cells that know how to track each other and change, but they if they're aware of each other, they will change, right? Because the system already handles that. And the UI for that is you can do actually a better UI because it's really a trivial exercise to put in cells and have text in between them. And unlike Jupyter, you can reorder the cells, you can rename the cells. There's a lot of things you can save your work and serialize it. There's a lot there's a whole area of people who are criticizing the weaknesses of various notebooks. And Jupyter was sort of the first major and the most successful one, but being the first, it also doesn't address many of these things because they really didn't think about those things. So there are other notebooks that are a bit better on some of these aspects, but basically a computational notebook is sort of a fairly straightforward exercise in this context. And the key thing to Jupyter's success is the ecosystem, that there are many, many things, computations and visualizers and things that you can reach. And that's what makes it actually useful. The idea here, at least from one guy I heard, is that there's enough stuff in the JavaScript world that we could attach to that we could actually make something that might actually be useful. Who knows? So yeah, it's on my list to do that. That is not a big exercise. It's a fairly small thing. The big exercise is keeping this whole environment with the language and the the whole system that does this and getting that to be robust and complete when it's just a part-time hobby for one guy. So, you know, it's this is not ready for anyone else to use, I think is fair to say. But it's getting to the point. My actual goal with this is no longer to take over the world like Java style and things, right? I have no delusions about that. My goal is to build a set of tools that I can use personally, so I don't have to use PowerPoint, and I don't have to use Pages, and I don't have to use Apple Notes and things like that. And there's still a lot of work to make that happen, but I don't have to. I do give real presentations with this thing. I do write documents for myself with these things, so it's coming along.
How do you think about breaking up computation? I
I'm
might
sorry,
want to
I missed
have
some keyword there. Could you repeat that again?
How do you think about breaking up computation? I might want to have some graphical thing that I can interact with low latency in the client on my browser, but then I might have a lot of data that's in the server to run queries.
Right. So this system, it's running in the browser, but there's no I could, if I didn't have to talk to you, I could disconnect the internet. Right? It's on localhost, right? It literally runs in the browser. It doesn't talk back to anything. It's completely hosted as a what used to be called an Ajax app, right? Now,
but do you also plan to have backend services be writable in Newspeak, or it's really a front end tool?
So that's just a matter of, yeah, there's a whole discussion to be had about, you know, this could be a front end to something else, right? So if I had the resources that I don't have, there's a nice core of an implementation, for example, on the Graal VM that Stefan Mar did, which actually performs really well. With taking it's basically a truffle-based interpreter, and you could run it on Java and say the backend and use this as a front-end UI to that, or to anything else. And
so the server story would probably be similar to Clojure or Scala. That
maybe
you rely heavily on existing Java libraries to do server things.
Purist, it would all be, you know, I wouldn't be talking with the conventional mechanics of website. At a lower level would do that. Basically, I'd have these would be actors, right? And I'd have this would be sending asynchronous messages to wherever, and I sort of wouldn't care what that wherever was. And it might be, you know, on my disk, or it might be on the internet, or what have you, right? That's there's also this whole thing about like the 3-tier separation of the UI. So whether these layers can be local or remote or both, or you don't care, right? Right now, the UI does call the views call to the rest synchronously. If this was done more using the async calls, then perhaps we could actually separate it so that it was independent, like the same UI would work without caring if something, and that's tricky to actually pull off with the right latency and all, of course.
Yeah, it's nice if the parts that cross the network can be all async.
Yeah. So it could be done. As I said, this is a part-time project that I am doing, and don't hold your breath for any of these features to happen really soon, right? Though the good thing, since I have no users, no one's barking at me to produce this on any timeline. So I have all the time in the world, supposedly. But yeah, we'll see. It has a lot of interesting aspects, I think, but it is not ready for prime time. In fact, this is a system that has devolved in a way, because when we had funding, we had a system that was almost at the point where we released it as open source, and if we had kept going for another year, we'd have a real product. But when you redo things, like we moved it from Smalltalk to the web, for example. We've done various things to it. We added features. All of this actually destabilizes. Everything works less reliably and less robustly than it did, 13 years ago. So that's just the way it is.
Who was funding you?
Cadence funded this. So that's a whole different story. But okay, the basics of this is that they wanted Cadence, for those who don't know, is a company that does essentially CAD software for boards and chips and whatever, and much of the electronics that everybody uses is designed on their stuff. And they wanted to expand to sort of a wider range of CAD tasks beyond electronics, and we were in internal incubation. And one of the key problems there was how to share this state of the design among disparate vendors and manufacturers and whatever, and this ability to, and Newspeak, one of its core unrealized things was the ability to save and synchronize the complete state across in a distributed fashion. That was actually the prime goal, which we never got to. And this now has echoes in what's called local first software, and CRDTs are perhaps a good way to accomplish some of this. And that's the major thing, that's the biggest missing part, which, because once I do that, then this thing will also synchronize, right? So I can use it instead of Google Docs or something, right? I can actually get it to synchronize across machines and so forth. That's actually the biggest missing part, but that was part of the design or the goals of the design from day one.
I had a question. If I can jump in. You kind of touched on it earlier, I guess, but I'm just curious what you think the tension is between like making an experience like this for the developer, where it's really live. I can change things on the fly and I get instant feedback, and then at the end of the day, I actually want something that runs fast. Are there trade-offs?
So there is I don't know, there may be some degree of trade-off. Mainly it's just more work, right? So all of this can be made. Another thing about Newspeak, the modularity is as a language, its main difference, its main claim to fame is the level of modularity, which is I'll in my characteristic modesty will say is unmatched by anyone. And one of the things it solves is Smalltalk had this deployment problem, right? How do you get your program out of the image? How do you get your product out of the development environment? All of these things were hard and complicated and required fancy tooling and never worked as well as they should, I'll say. So Newspeak being modular, it's fairly easy for us to deploy programs separate from the development environment. And if your program, in fact, does not, use the mirrors capability, once you've developed it, it actually doesn't do that, then you can compile it just as you would anything else, right? And you can throw out, you don't need to keep all this stuff around, but you do need to have a system where you can run the development environment, which means you should be able to change things on the fly. And so you typically have these systems which have an interpreter and a JIT. An interpreter kicks in when you're doing changes and things like that. And they have to interoperate, and they have to be able to, the JIT has to be able to de-optimize all the way back to let the interpreter do things. And so it's a ton of work to do a high performance version of this. But this is just an interpreter, right? To be clear. But there's no reason, if I had, say, 5% of the effort that has been poured into Java, we would have a system that was almost as fast and far nicer and with far less issues.
5% of the effort poured into Java is a lot.
That is a lot. That is a lot. And I'm throwing out a number. I think 5%. I'm being conservative. It probably, if I had 10% of what was poured into Java in the first 3 years, that would probably be enough, right? So the Java, once you have such a history, there's been tons of effort, and a lot of it is just over and over revisions and things. So it's in the billions by now, I think, in terms of money. But you don't need a team of on that scale. You need 5 people for 2-3 years. The right people, some of which are here, but I don't have any money to give any of them, so it won't happen.
I'm less motivated by money these days, anyhow. My price has gone up because I'm no longer so desperate.
Yeah. Well, that makes it easy, right? Yeah. So anyway, it can be done. It's more work and applications. And there's also a tension between how you want to make, if you want to do an application like this, say I was putting out a presentation tool, right? I decided to compete with PowerPoint or something, just as not as a serious idea, but just as a hypothetical, right? So I actually want this rich environment, right? This actually is tied to it, because I want the ability to change it on the fly and add things, and then I do have to carry the development environment with it, right? So then there's this tension, and you have to think about all those things. So it needs more work, but only sort of locally, right? Because these other systems, they have the property that they need less work up front, and they need endless work for decades to come because there's always something new they can't do, and you have to redo them over and over again, right? So it's just long-term versus short-term, and short-term always wins.
Yeah. Suck. I get that.
This is life. Okay, where are we now? Yeah, it's almost 12, which is my hard deadline, actually, so it's perfect. Thank you for suffering through this, and you guys
It's our pleasure.
You guys can continue. Where did the stop share button go?
Yeah, thanks for coming to talk to us.
Or else kick me out, Cliff, because I can't. Where did this? This should be their little red thing. Oh, there it is. Yes.
I want to see a cage fight with you and Alan.
Okay. Well, thank you very much.
Yeah, thank you.
Very good to see you.
It was a delight. It was wonderful.
Yeah.
Take care.
Thank you. So round of applause for Gilad.
Yeah.
Bye now.
All right, sir. I hope to see you again.
Absolutely.
There you go. Well,
I will say
noon.
that N by M problem is definitely a real one. The number of times I've seen what I thought was going to be a tiny change that ended up touching 54 classes, and you're just like, why?
Yep.
Well, I mean, like the reason I like Jupyter so much is because it exists and everyone uses it, and it's like, and it's not that hard to write a Jupyter notebook. Like he was saying, you need what is it, like 5 years or no, 3 years and 5 people.
Well, that's because he's doing a Newspeak, not a Jupyter notebook. I think those are orders of magnitude different.
Yeah, but like, I mean, if the choice is a Jupyter notebook that works, that I can write in a few days, and a workspace that never gets done, I mean, I take the Jupyter notebook.
I mean, that's completely different things. I mean, the Smalltalk community has done their thing for like 40 years. I mean, Jupyter
I'm not
exist
saying it
for like
wasn't
30.
nice. I mean, like I was reading about, it's the Frank project from the Viewpoints Research Institute. They like wrote this whole workspace environment from like the ground up, and it like has its own programming language, its own graphics stack, its own everything. And like, you know, they were doing presentations in it too. And like the whole point was like, it was really short. It was like 10,000 lines of code or something. So, but I mean, you know, nobody uses it, you know, and it's the same story. They ran out of funding. So.
Yeah, I mean, popularity and quality is not necessarily connected.
Yeah,
it's not
Jupyter is popular, so you write a Jupyter notebook, and that's all you need for your language to get popular.
No, well, I think we just heard Newspeak not being popular yet, so I claim that.
No,
he's yet adequate.
He's like, he's not aiming for world domination. You know, he gave up on that.
Yeah.
You know, I want world domination. So
because quality doesn't bring you there. I mean, if he
definitely got some cool shit going on there.
I still think that bridging the gap between the interpreted environment and the actual, these are the text files that get deployed in production, is a path toward world domination.
Yeah.
Like right now, it's super hard to be like, something crazy is happening in production and I need to go look at that production environment, and I just want a REPL that I can connect to the thing and ask it questions. And
but
like
the flip side of that, and this is where it, as he was talking, it was reminding me kind of you know how people look at DNA and they're like, well, it's just code, right? So all you have to do is find an interpreter for DNA and you create life. It's like, no, it's not that easy, because life has a state to it, right? So there's state plus code, right? It's not just state. It's not a frozen state. It's a running state.
Yeah.
Plus DNA is code, right? So it's like, so in a sense, that's what Smalltalk was, right? It's like the state that you have does not have a code representation that gets it back to that state.
Yes. Yes.
Like they literally could not rebuild what they had in terms of an image. And Bill, correct me if I'm wrong, because I know you were there, and I wasn't. But there's a complexity, there's a living complexity to small talk and to what we saw today as well. And and I'm not saying it's a bad thing. I'm not saying it's a good thing. I'm saying it's an incredible thing that it works at all. But it has, Aaron, to your point, has a different set of problems in the reproducibility side, for example.
A key thing, I think, if you want your world domination, is to get back to the state of man now. A button that says "Get back to the state of man now" from whole cloth, in a viewable, visitable, editable. I can understand what's going on. Whether it's replay your interpreter or whatever the hell it's going to be, there is a program that can be statically generated that produces the state I'm at. And that's sort of the key missing bit here.
Yeah, I need auditable, reproducible builds that I can testify about before Congress.
Yeah.
And Aaron, the other side of it is it's like, okay, I'm having a problem in production right now.
Yeah.
Like, fork that problem for me. Right, like somebody take a snapshot of the state right now.
What was one of the Azul winning things with the original Zing thing was I could attach to a running JVM and give you at least a heap surfer. We didn't execute arbitrary code, but I could inspect every instance of every class and everything and all the JITted code performance bits, but you could look at just every possible thing like you had a debugger that was read-only. And it wouldn't impact your performance, but it would let you inspect the machine.
Or A/B it, kind of like fork it at this point, so I could, what if I, give me the thing I can examine the problem in, but then make it mutable for me without leaving the, without impacting the user.
I think that's a harder one because you can't draw the line of where you clone it. Like I've got a running server, it's taking load. I clone it, I got 2 running servers. Okay, I want to debug the second running server, it's not taking load no more. So if you let it run on, it quickly hits some stable state and the bug goes away. So you could freeze it and then inspect it as a frozen snapshot, but I was giving you that already on the running system.
Maybe cloning the server is too much for the stability sake. Yeah, if you clone the server, you get exactly to the state you want. But if you clone a function or a call stack, small call stack, and you try to change it, then the change is much more localized.
Well, there's a change. I wasn't even talking about change. Like inspection, like find the bug. So the clone thing's easy. I go to my Docker container and say, snapshot you, give me an image. I'll go take it back to my desktop and break the image open and see what's going on. But that only gets me up to a point because like what's inside of a running JVM? Okay, now I whip out the Azul thing attached to it. Okay, the server has frozen. If I don't let it run on, but I do let it respond to web requests to inspect its state, maybe I can tell you something, right? And that's, flight recorder kind of thing. So go give me a heap dump or whatever. Effectively, it was giving you a heap surfer, heap dump on the live VM. And if you snapshotted it, you got the same thing. But the notion that I could clone a running system and have a second running system that I could torture with freely, that's not there yet.
Yeah,
because I can't apply that load to that second running system. Yeah, soft ice. Yeah. I worked with systems that had ice. It was very nice. Very expensive.
Well, I don't know. I mean, like obviously the talk he mentioned that like the splash talk about the interactive time traveling debuggers is going to get into. I mean, it's not online. I checked, but I'm assuming it's going to go online in the next week or two once the conference is done.
Elm does a time traveling debugger, or has had in the past that I've used.
Yeah.
And that's because they run a purely stateless model, and so they can just capture your events and then replay them forwards and backwards. And the answer was the implementation had a quadratic slowdown over time. So if you could find and fix your bug in the first 5 minutes, you were okay.
Well, I mean, but like you don't need it, right? You just think hard about what your program is doing.
Exactly. Why do I need a debugger? Yes.
I think Clojure actually has a pretty good model toward that of using persistent data structures for things, and more of our databases have started to look like log structure merge trees also that have more of a persistent. I'm going to fork off and say, here's what the database was at that time and the state in my system was at that time. And really,
now
you're going to pay a 100% penalty the first time for switching to those persistent data structures, but it's not going to be quadratically getting worse over time. It should just be, you have half the performance. Okay, now you're okay.
Yeah, maybe. Because you pay a continuous cost if you're logging every step, but that's the 2x slowdown in the first place. And maybe that's acceptable. The Elm situation was sort of intolerable at some point for being too slow, but that might have been implementation restriction.
Right. Closures things is not that it logs everything so that it gets terrible. It's that you at this moment say, I'm taking a snapshot, and you have a persistent data structure that shares state. And the new thing goes off mutating in its way, and you go off mutating in your way, and the garbage collector is trying to deal with anything. And simply because you kept a pointer to something around, it never got garbage collected.
I wanted to debug a process, so I want to snapshot it here. Then I wanted to go back, so that's not a reversible thing yet. So I took a series of snapshots, and I can go back to any prior one and presumably step forward. And I stopped the guy who's running forward at some point, just so I don't have to pay his cost to keep producing garbage. And I'm running back and forth in this region. And what's the overhead of running back and forth from these snapshots? I can go back and then replay the snapshot going forward. And the whatever was going on in Elm, the cost model rapidly skyrocketed. It was, user mouse clicks and motions. Now the debugger attaches and it can replay those user mouse clicks. That was nice, but getting there and the speed involved was very painful.
Yeah, I think ultimately we're going to need exponentially declining backoffs. That's like, for the last second, I've got millisecond snapshots. And then for the last minute, I've got half a second snapshots. And then for the last hour, I've got 2-minute snapshots. And for the last day, I've got hourly snapshots.
Yeah, I can go back in time at exponential scales and then pick a point. But to be able to replay
if you want to look at 7 years ago, sorry, you have to move forward and backward by an entire month. You're looking at 7 years ago. Deal with it.
Well, the problem I have is I can't go backwards an hour and then go forward in millisecond increments unless I've recorded millisecond level data. So all I can do is jump back and forth between these two different snapshots, which it's a step up from where we are, that's for sure. But it's not, I don't know, fine. The H2O debugging model was, we ran hard and fast at nano to microsecond latencies between nodes, because that's the speed of a UDP packet crossing an internal data center network. And then a crash happened. And then, the volume of data you turned through was far too great to record. So I only snapshotted a history of effectively a handful of seconds. And if I caught the crash within a handful of seconds, I could stop everybody, gather up their logs of the last several seconds, and hand you a debuggable pile of shit. But if your crash was a dropped packet from 2 minutes ago, I would just be out of luck. Okay, we're all hanging, waiting for somebody. Why are we all hanging? Dump the world and look. Oh, we dropped a packet. We dropped a message. Where did it come from? When did it get? No one knows. It's not in the logs.
So funny story about that. We were talking about this many years ago, like early 2000s. And there was a product that actually recorded all of its network traffic so that it could reconstruct what happened. And they were saying, well, do you do that? And I'm like, no, because we produce, gigabytes of network traffic per second. Like, there's no device that we could store it on. Just people don't get this. They don't get
control messages. For me, it was control messages only. The bulk of data things, there was hi, I'm transporting this entire data set from A to B, but no, it didn't show in the log. And the log was like per thread ring buffer that had a nano time and a event header tag bits, a couple of it, and that was it for the events. And anything else was too high volume to do. So severe compression on the tag bits. And then actually the fun one was I had broadcast, 3 broadcast messages, and one was, I'm making a cluster, are you out there? Or I'm adding myself to a cluster, whatever. And one of them was, I'm sick. Everyone dump, puke your dump out right now and stop doing anything else. And that was, like the only handful of broadcasts, but one of them was, I'm sick. Everyone puke and die. And then the guy who claimed sickness would gather all the pukes and sort them and pretty print them, and the debugger would lock in because you hit a breakpoint, and he would say, and here is the pukage from the state of the universe at a nanosecond interleaving scale. Painful, but that was never mind. That was the debugging process of that time. All right, well, here we are. It's 12:15. We seem to have wound down, so I'm going to call it.
And Darrick just got back.
Yes, and Darrick caught.
I'm not surprised I'm too late.
It's perfect timing. Perfect timing. I'll have more of an AA update next week, but I'm back to working on the main code base. I have all my other bugs sorted out. Oh, variants. I was going to say the variants. I thought I showed it last time. I got the variants thing well sorted out. Like, I believe I can do it without regards to any other things. I don't know if I have virtual dispatch semantically correct yet. I'm thinking about how that one goes, but I think I can get there as well. That would give me some blend of subtypes and interfaces and mix-ins, all with a pure theory behind them, and then I can implement something reasonable after that.
I got my my splitting the. I think I mentioned that I was dealing with state chains through the system, and I have this all state chain which I start with, and then I peel it apart.
Yep.
I got all that working, and then I realized that at the beginning it peeled into multiple strands. Yeah. And I have to peel it from back to front, so I had to redo it. I actually just got that working yesterday.
Yeah.
But
yeah. And you want to remerge at points. Well, you may not care.
So
I wanted to remerge.
Yeah, so instead of remerging at points, I just added a little clean marker, and so everything after clean is already fully peeled apart, and I just work from back to front, and the all state chain has to go that way. And the other thing that I did is I got sick of having compiles not complete because I forgot to add things into my work list. And so I just, every time I do anything, I just add every node back into the work list. It makes things slow, but it guarantees that it works, which is where I need to be.
So for my incremental world, like if I'm debugging, I have progress bugs and I have value computation, whatever, optimization bugs. Progress bugs are at every minor step when I did something, I go check the entire work list, and anyone who could make progress is on the work list. And therefore I can always ask a guy, would you make progress, as opposed to just test and do the progress. He has to have a state that he tests and then he doesn't do. He just says, yes, I would. And then that makes the assert go quadratic because it tests everybody at every small step. So I turn that assert on or off because it's too expensive. But if I'm hitting progress bugs, I turn that one on. I get the guy who made progress, who immediately should have put somebody on the work list but did not, happens in the one step removed.
That's way smarter than what I did.
And then
I just was like, this is bugging me. I gotta get past it immediately, and I did the dumbest thing I could.
Right.
It's a good idea.
All right. Good enough. Let's meet next week. Let's see. Still not yet in the holidays. We're getting close though.
Okay, one more.
All right. Till we meet again. Bye-bye.
Bye.
Yep.